Hi class. So we're skipping 4.6 because it was part of the complete lesson we did last week on all the exponent rules. So I'm going into 4.7, add and subtract polynomials. So anytime you have a polynomial, and as a reminder, a polynomial is an expression with more than one term. So a term can consist of a coefficient and a variable, or more than one variable combination. So a leading term is a term with the highest degree in a polynomial. So if you have a variable, so for example, here we have a variable and a variable, but this 5x cubed ends up being the leading term because the exponent for x is the highest. So this is a leading term. And a leading coefficient is the number in front, or the coefficient of the leading term. So if I use the acronym LC for leading coefficient, we can see for this expression A, the leading coefficient is 5. And if we're to order these with the leading term first, we would have this is equal to 5x cubed plus 6x squared, or 6 to the power 2, plus 4. So it goes from the largest exponent for the term to the smallest, which is none, for 4. If we look here, this is actually already in order. And actually, if I jump back to part A, is it a monomial, binomial, or a trinomial? Well, since it has 3 terms, then we know it's a trinomial. So question B is already in order with the leading term already first, but what's the leading coefficient? So if there's no number in front, we know that the number in front is 1. So we would say the leading coefficient is 1. And this is a binomial, trinomial as well, because there are 3 terms. Now we look at these 2 terms, and while you're watching this video, at any point you can pause it and try it on your own first, and then start it up to confirm your answer. So if we look here, which term has the highest degree? And it would be this one because it has the squared term. So we would rewrite this then as negative 4a squared plus 2b, where the leading coefficient is, that's right, negative 4. And is it a monomial, binomial, or trinomial? That's right. It's a binomial because there are 2 terms. And it's saying, are any of the terms in each question like terms? What's a like term? It has, so a like term has the same variable with the same exponent. And it could have more than one variable as well. We'll see, I think, in a future example. More than one variables, possibly more than one, and the same exponent. So this question's asking, look at each question individually. Are there any like terms here? Well, there are 2 terms that have x, but their exponents are different. So no, they are not like terms. Again, similar situation here. There are 2 terms with x, but this one has an exponent 2. This one has an exponent 1. So remember, if you don't see the exponent is 1. So no like terms here. Here, binomial, 2 variables, 2 terms. Both of them have different variables. So in terms of this question, the answer is no. None of the expressions have like terms. So now moving on, we'll do a couple of examples of adding and subtracting where the variables are different from each other in the expression. It's easy to identify like terms because they'll have the same variables. So for example, this term has a b and this term has a b. So those are like terms. And then here, negative 4a and 7a are like terms because they both have a's. And if we combine them, we combine their coefficients. So here, if there's no number in front of b, that's the same as having a 1, right? So if I first rewrote them and grouped them together, and let's say I do it alphabetically, just to pick an order. So if I had negative 4a plus 7a, and then plus 10b plus another b. So we can only combine the coefficients of like terms. So I look here, and we have negative 4 plus 7. So that is 3a. So it's like saying I had 7 apples and I take 4 away. And the next example, or the next two terms, we have a 10b and 1b, and they're all being added together. So then we're going to end up with 11 b's now. And that would be your final answer. So you cannot combine these two terms because they don't have the same variable. Now looking at the next question, we have one term here with a t, 6t, and negative 5t. And then we have 7w and 9w. And we rewrite it, grouping them together. We have 6t minus 5t. And then we have 7w plus 9w. And just like the previous example, we'll look at the like terms, this set and this set, and we can combine their coefficients. So 6 minus 5 would be 1t. So 1t we can simply write as t. 7 plus 9 is 16, so then we would have 16w. And that would be the final answer for this question. So now with this example, all the variables are the same. So here we have all x's, and in this question we have all x's, but the exponent is different. So therefore, the ones with a different exponent are not like terms with something with another exponent. So step one, what you would want to do is first rewrite the expression without the brackets. So this one is easy to do because there's no number in front here, there's no number in front here, and this is a plus sign. So we simply can write it out without the brackets. And now you want to define, identify like terms. So I can see here I have one term with an x squared, and I scroll through, and here's another term with an x squared. That means those two are like terms. Here I have a term with an x, and here's another term with an x. So those are like terms. And then finally, we have a number here, and we have a constant, and another number here, or constant. So anything that's the like term is what we can combine. So if I rewrite this, and you don't always have to rewrite it, grouping them together, but if it helps you to understand at first, it's a good idea. So here I would group together the x squared terms, so x squared plus 2x squared, and then I have minus 6x plus 6x, and then I have minus 2 minus 5. And then we look here, and now we can combine the coefficients of the like terms. So 1 plus 2 would give us 3x. Oops, I wanted to change the ink color. 3x squared. Minus 6 plus 6 is 0. So that term gets eliminated. They cancel each other out. Minus 2 minus 5 would give us minus 7. So this would be your final answer. You can't combine them anymore because they're not like terms. Moving on to the next question, what you might want to do is you can pause the video and try to work this out on your own. It's probably suggested, but the tricky part now is that there's a negative sign in front of this bracket. So it's like multiplying each one of these terms by -1. So pause the video and try this out first. Welcome back. So the first expression, because there's no number or negative sign in front, can just be written without the brackets. Now -1 times -4x would give us positive 4x squared will give us positive 4x squared. -1 times -5x will give us 5x positive, because a negative and a negative makes a positive. And then -1 times -8 will give us a positive 8. And now we find like terms. Identify the like terms again. So here we have an x squared term. Here's another x squared term. So we're going to be combining those coefficients. And again, pause the video and try it first on your own. There's an x term and another x term. And there's only one constant term. So that one would stay on its own. Now rewriting it, let's say I solve it without grouping it together to show you that that's okay too. If we have 2x squared and 4x squared, we're adding 2 and 4. So we get 6x squared. 3x and 5x, we add the 3 and the 5, so therefore we get 8x. And then finally the constant's on its own, so we simply have 8. And that's the final answer for this. So the last two examples I'm going to put in a separate video because I'm using a program that has a time limit on videos. So stay tuned for part 2.